Hello, good morning, everybody. Thank you for joining us today. What I'd like to cover is some of the functional safety offerings that are available from Keil and ARM for Cortex M microcontrollers. There are a number of different industrial and different sectors that use microcontrollers and have safety-related concerns. And as a company, we've seen a number of projects, particularly in the industrial area or consumer area, that have adopted Cortex M microcontrollers for safety systems, but probably less so in areas such as automotive and avionics. So these are kind of growing areas for Cortex M Micro. I think the restriction here has mainly been that the silicon vendors haven't really produced devices where the hardware is suitable for these environments. However, that's starting to change now, particularly with devices like the S32K from NXP that are fully qualified for automotive systems. So now that the hardware has started to get there, there's more of a demand for safety qualified software. So within these industries, there are a wide range of standards that any qualified software needs to support. Many of these are derived from IEC 61508 and have particular industry-specific versions of that. So much of the tools and the software that I'll discuss today are qualified across a wide number of standards to try to make them applicable to as many applications as possible. But as we go through, we'll have a look at the different certification that's available. So there are a number of safety offerings that are now available for Cortex M microcontrollers. For many years, the ARM compiler has been safety certified by TÜV. So there's a couple of versions of the compiler, and both of them are now safety certified. In addition to the basic compiler, Keil and ARM also provide a certified ANSI-C library for use with the compiler, and also a functional safety runtime system that provides you a number of reusable components that you can use in safety-related projects. All of these integrate very tightly into the Keil MDK, so you can have a safety-related tool chain that is pretty much the same to use as the standard MDK. So this gives us a very easy way to adopt safety software and begin development fairly painlessly. So while it would be possible for you to certify your own tools, this is quite a complex, long-winded process. So however much effort you think it would take, you can probably double it and then also put a naught on the end of the cost. So really, the only practical way to start development on your project is, where possible, to use safety certified tools and components. It will get you going much quicker, and then the certification is maintained over time as well. So to look at the ARM compiler for functional safety, first of all, there are two versions of the ARM compiler that are safety certified, and it's pretty important to be clear on what's available here. The original compiler that was certified was the ARM version 5 compiler. So this was certified up to SIL3 usage and is still certified and available. But really, it's now reached the end of its lifetime. So while it's still under maintenance, it won't be really further developed or carried forward into the future. So now, if you're starting a safety-related project, there is new version 6 of the compiler. So this is a completely new code base. It produces more efficient code, smaller code, and is also fully certified up to SIL3 usage as well. So this comes with complete TÜV or TÜV certification. And again, it's important here to understand that this is really for the compiler toolchain. So this is all of the compiler code generation binaries. So the compiler, the assembler, linker librarian, and the final image conversion utility. So everything that you need to get from source code down to an Intel hex file. And what it does not include within the compiler is the ANSI library. Okay, that's available as a separate product. So we're talking about the certified compiler. It's really the compiler linker toolchain. Okay, and again, the one to look at here is the version 6 compiler. Again, that's really the future of the ARM compiler. So this compiler now provides a baseline for the other certified components. So sitting really on top of the compiler, we have a certified C library. We have the functional safety runtime system, and there are also software test libraries that are available as well. And the certification for all of these additional components relies on you using the ARM compiler. So the two sit together. They've been certified in tandem. And the compiler and the components you can use standalone, or they will fully integrate into the ARM toolchain. So the ARM Development Studio, particularly if you're going to use Cortex R or Cortex A devices. If you're working with Cortex M or some of the Cortex R devices, then the MDK provides the ideal platform. Again, this was certified by TÜV, I think probably a couple of years back now. So again, you get a full copy of the certification certificate. And then alongside the certificate, there is a full qualification pack for the compiler. So this includes its safety manual, defect report, test report, and the development process as well. So this can be downloaded as a pack of documentation that sits alongside your own safety documentation. This is available alongside the Keil MDK Pro. So the certified version of the compiler is automatically included with the top level Keil toolchain. Once you have the Pro license, you can download and install the safety version of the compiler, and also the product serial number entitles you to download the qualification pack as well. So it's all very easy and straightforward to do. Once it's set up, again, you really just use the tool chain as the standard MDK. The ARM compiler is still under continuous development. So we have the mainline branch, which is the standard compiler that's used within the MDK toolchain. But we have a separate safety branch that's maintained, and any appropriate safety fixes are then built into this safety branch. So this is a separate branch of development that is still under maintenance and long-term maintenance. So the compiler is guaranteed to be around, really, I would think, at least the next 10 years or so. The ARM version 5 compiler, I think, was around for like 15, 20 years, possibly longer. So it's a good, stable, long-term product. As I said, the compiler sits within the MDK Professional or the ARM Developer Studio. And then once you have the license, you can fully download all of the certification, qualification pack, etc. And that sits then as documentation within the MDK. Just here as a summary, so we have the certification levels. We have as standard the Windows version, which is again used with the MDK, but there are also Linux versions of the compiler as well, if you want to use it under a different operating system. Again, I would emphasize the important thing here is that the certified C library is not part of the standard compiler product. That's purchased separately. Another thing that you should be aware of is that when you purchase the compiler, depending on the tool chain that you buy it with, there's a different range of processors supported. If you purchase the standalone compiler, it will support all of the ARM cores from A, R, and M. The same goes for the ARM Developer Studio. But the device support is restricted within the Keil tools to just the secure core, the Cortex M devices, and the earlier Cortex R devices. So again, depending on your use case, it will maybe vary a little bit on how you source the compiler. So alongside the compiler toolchain, ARM also offer a certified version of the C library for use with the compiler. Again, this is certified over a wide range of standards, and it's certified as a safety element out of context. So this makes it a reusable software component that you can use across multiple projects. Again, it comes with a TÜV certificate and a similar qualification kit that again we can download. It provides a subset of the standard ANSI-C library, so there's some restrictions, and it also produces the ARM runtime ARM binary interface. So this gives it a standard interface that can be reused with other software components. And again, the URL at the bottom will provide you full details of the functionality that's supported within the library. Once you download it, again, you get the qualification kit. So this sits within the MDK, so it's available online as documentation through a mouse click. And also we have a copy of the TÜV certificate to include with your documentation as well. Now, the licensing for the C library is slightly different to the compiler. When you buy the compiler, you have a perpetual license that you can use for as many projects as you want. The C library is purchased and licensed for a single project and a single project. So you can buy the compiler, have it as a perpetual license for a given project. It's also available as a term license, so you can buy it so that the license will expire after a year, but in that year you can use it across multiple projects. So depending on your use case, you may either buy the library as a perpetual license or a number of term licenses. Again, it depends which works out as the most cost effective. Again, here we have a summary. So this supports a wide range of the ARM Cortex M microcontrollers and also the ARM processors. But again, you just have to consider the licensing type that you will require. Now, alongside the compiler and its certified library, over I think about the last year, 18 months or so, Keil have also developed a runtime safety system as well. So this is a platform that you can use to start to build your safety system. Now, so this includes a number of reusable components. And again, these are certified across a wide range of safety standards. At the heart of the runtime system is the Keil RTS operating system, RTOS. So this has the CMSIS RTOS v2 API, so it's the same to use as their standard RTOS, and it provides a full preemptive real-time operating system. Now, alongside the RTOS, there are a number of other components that are included. So inside the functional runtime safety system, there's also a version of the certified C library, and also a certified version of the CMSIS core specification as well. So this is a certified version of all of the low-level functions that are used to talk to the Cortex processor. So again, this gives you a standard. You won't need to go through and develop all of this low-level code and have it tested and certified. There's also included in here a certified version of the event recorder as well. Now, this is a debug agent that sits on the chip, and it can provide instrumented messages to the development tool, but it's also very useful for getting code coverage and timing information out of the device as well. As it is certified, it's possible to leave the event recorder agent inside your application so that during the early stages of prototyping and beta testing, you can have the functional safety code in there and still be able to pull out detailed diagnostic messages. In addition to the runtime system, there are a number of software test libraries. So these are separate products which are purchased separately through ARM, but these are software test libraries for their different Cortex M processors. Some of these software test libraries are now available directly from the silicon vendors as well. And they will provide, or they attempt to exercise every gate on the processor to validate the operation of the processor core at startup. Now, you think you might be able to write one of those yourself, but it's actually quite a difficult thing to do. Most libraries that are sort of self-written will get a coverage of between 30 to 60%. Whereas you need quite a deep understanding of the processor to write a successful test library. So the ARM-derived ones typically will cover in excess of 90% of the gates. So again, if you need a software test library, these are available as a separate product and are licensed through the different cores. So the runtime safety system, so there are a lot of safety certified RTOSs that are available for Cortex M, but the Keil one provides additional components of the C library, the event recorder, the CMSIS core, that give a much broader offering than just the pure RTOS. So it gives you actually a platform that you can start to develop your code on straight away. All of these are really certified components of existing software that's within the MDK. So this is widely used, widely understood, and you can then switch over to the safety components and really carry on developing fairly seamlessly. So it's pretty easy to upgrade and get going. So this gives you optimized support for a very wide range of microcontrollers, somewhere about 6,000 MCUs. So that number is just getting bigger all of the time. The way that the functional runtime library is licensed is similar to the C compiler. It's licensed for a particular core, so you'd license it for M3 or M4, and it's also licensed per project as well. So you can pay the one-time license fee, and then it can be used by as many developers as you want. So it's not licensed per seat. Once you have licensed it, that is all of the costs. So it's effectively royalty free. So you only pay the development cost for the functional safety library, and then you can produce as many products as you want. This includes also year support and maintenance, and after that year you can purchase additional support contracts. And again, it doesn't come with a complex legal contract. Again, it's just downloaded and you have a click through to install and start using. But again, the one thing that I would emphasize is that you do need to use it in conjunction with the MDK Professional. This has the certified version of the compiler, and the two sit together. You can't use the functional safety library with a different compiler. Its certification then won't be valid. So to install, really, it's downloaded and installed as a software pack. So once the pack's delivered to you, and you simply click on it to install it, it then integrates directly into the Keil MDK. So you can then select the safety components directly through the runtime environment. And all of the appropriate documentation is then available as hyperlinks. There is, if you're interested in trying out the functional safety library, there is an evaluation version that's available. So if you get in touch with either Hitex Germany or Hitex UK, we can get you a link and a username and password to download it. You can then install it and try it out, and this is pretty much the full product. There are a few limitations and some restrictions on the documentation. The major restriction is that it will only work with Cortex M3. So again, you can try it out, but it's pretty much the same to use on other cores as well. But apart from that, it's pretty much the real thing. Again, here we have a summary of the components available and the standards that are supported. But if you're familiar with the MDK, you probably use much of these components already in the system, and you just transition to them in a pretty straightforward manner. So all of this, as I mentioned, sits within the Keil MDK. So this is the standard IDE that's available. So this includes the Microvision IDE and its debugger. Software packs that were provided by the silicon vendor. So ideally, if they have a safety related device, they'll provide safety certified libraries and drivers. We then have CMSIS core, which will be safety certified to sit on top of that. Within the MDK Professional, there's also a range of safety middleware as well. This isn't certified, and it's unlikely that it will be in the near future as well. So I don't know of any plans to change that. So we have the CMSIS core, and then also the safety version of the CMSIS RTOS. Then the MDK will interface with a number of the Keil Ulinks, so the Pro, the Plus, and the Ulink 2. For safety work, the Ulink Pro will connect to the instruction trace that's within the different Cortex processors. So this will then enable things like code coverage and performance analysis within the debugger as well. So this gives you very powerful view onto the chip for safety certification. Ulink Plus also provides information about power usage as well. So again, if you want to profile it for low power operation, Ulink Plus will give you an invaluable amount of information. So within the MDK, as I say, we have the safety qualified compiler. You can integrate static analysis tools as well. So there's things like PC-Lint, Parasoft, so we can check to various safety standards. As I mentioned, if you use the Ulink Pro, we can get streaming information. So this will stream every instruction that's executed down onto the hard disk of the PC. So you have essentially a trace buffer that's the size of your hard disk. So that allows you to do very extensive performance analysis and code coverage. While there are coverage tools within the MDK, we can save off that information in GNU coverage format, so you can use third-party tools to test it as well. The MDK is also available with various simulation models as well. So these basically allow you to run your code on a simulation of the Cortex processor. And depending how you've structured your code, that can be quite useful for software testing and also analyzing bits of the C code that are isolated from the microcontroller peripherals. So again, simulation models have a very good role to play in testing and validating code. Currently, ARM are working on a CMSIS build specification. So this links up to build tools such as Jenkins and other continuous integration servers, so that we can use the standalone compiler to run automated testing as well. So again, this is something that will come on stream a bit more over the next 3 to 6 months. As I mentioned, there are a number of fixed virtual platforms that are available. So these are simulations of the processor. That doesn't include any of the microcontroller peripherals, but again, they're very useful for software testing. Within the debugger of the Microvision, we have a lot of RTOS awareness. So there's a component viewer that will show you a very deep view of the state of the operating system. And as I mentioned, the event recorder will put out a lot of instrumentation information about the operation of the RTOS as well. So again, you can get a very deep view of what it's doing in terms of its memory usage. The event recorder has specific support for timing analysis, so you can measure between points in your code, and that will give you max, minimum, average runtime, so we can get quite a lot of detailed information. There's also an event viewer trace that gives us a timeline between all of these events as well. So again, we get a good, deep, solid view of how our code is operating. Outside of the Keil and ARM tools, there's a wide range of safety partners, again, both silicon vendors and tools and library vendors. So again, this is a growing and strengthening area as ARM microcontrollers get more widely used in safety applications. And over the years, ARM has started to take more of a methodical interest in developing safety processes, both within their own IP, their safety certified software components, and also documentation and certification as well. So again, this is an area of growing importance for them. It's fairly safe bet that their microcontrollers will be supported more widely in the future. So I'd like to thank you for joining us today. If you have any questions, let us know via email.